Jæja, góðan daginn, velkomin öll í þennan síðasta fyrirlestur þessa árs. Við erum hérna með Jesper Flutter sem mun tala aðeins um Azure og monitoring og management á Git. Og hann hefur komið hérna áður til Íslands og verið með kynningar hérna og við munum aðeins hérna sjá hvernig hann hefur hérna síðan þetta. Jesper er MVP í Azure og mun svo hérna með mikla þekkingu, hefur talað á Ignite og fleiri hluti. Þannig að við erum bara þakkum Jesper fyrir þetta. So thank you Jesper for giving us time for this lecture. It was a pretty soon fast that you gave us this time, so thank you for this. So I'll just give you the torch and we can start. So
thank you. Yeah, I'll just share my screen here. And some words about me. My name is Jesper, as Gisli already said. I changed my last name, so you might have known me like Jensen. Now I'm Bing instead. And I'm a cloud architect and working with customers all around Denmark and sometimes outside of Denmark too. And a few years ago, I got the title of Azure MVP. So you can find me on Twitter with the handle in the bottom here, and also on GitHub, where some of this code will be uploaded, so you can see it later. So the agenda for today is around management and monitoring in Azure and how we, as an MSP in Denmark, a small MSP, have developed our tools and the processes around this, getting to a point where we can manage customers easier. So we'll get a backstory of where we came from, what we've been through to get here, and all the thoughts and considerations we've had on the way, and still have. We wanted to focus on having reusable code. So we have to do the least amount of work every time we get a new customer, or if we have to deprovision a customer. We want to be able to deploy it to multiple customers. And then I'm going to tell you a bit about what we learned on this journey, and where we're going, what's next. If you have any questions, just feel free to ask them. I might not see the chat, but I guess Gisli, you could tell me if there's some questions, and we can look into that.
No problem.
So this slide, if you were at Ignite 2019, of course you saw this session I had there. This is 2 years ago now, and we talked about where we came from back then and where we was at that point. So this is kind of the version 2 or whatever we should call it. So it's just an extension of this session then. So the story, as I said, we're a small MSP house. We came from a past where we had a System Center Operations Manager in-house, where we monitored customer environments. The customers didn't want to handle alerts themselves and filtering false positives and all that. So we managed that for them. About, I think, 7 years ago, maybe 8 years ago, we moved our servers to Azure. And we ran them for, that might have been 5 years ago then. For 5 years in Azure, and learned a lot on that. But we still wanted to develop this offering we had. We didn't feel like Operations Manager was the way for us to continue doing this. And we actually saw a drop in customers because they wanted something smarter, more flexible, where they could easier come questions for us for new features. And maybe they could develop something themselves and have that hook into our monitoring so we could handle the alerts for them. So 2 years ago now, we moved, 2.5, 3 years ago actually, we moved into Azure Monitor. That took quite a while, and we had to develop a lot of ARM templates with alerts and all the resources we needed. And handle all that. I have some numbers here. So where we came from, we had one Scrum management group and 3 servers. We had a gateway server at each customer. We had a lot of different management packs and third-party management packs, and some we developed ourselves. In a random week, we got about 300 alerts. 200 of them auto-closed within a short time, so we didn't actually need to do anything about that. And we handle about 100 alerts. So in the company, we are 14 people. Actually, we are 15 now. Still 9 consultants and no developers. So that was the challenge for us, because the consultants are usually on projects and don't have time to handle these alerts. So we needed something where we could get rid of all these auto-closing alerts, because if they're closed within 5 minutes, or if we don't need to do anything about it, there's no need for us to get an alert. So we managed to reduce the number of alerts to just the ones we actually need and filtering that. The solution each customer got was one Azure subscription, and they got this through CSP, through us. So we deployed an Azure subscription, and we had the control of that subscription. In that subscription, we deployed a log analytics workspace, an automation account, and then we deployed one or more action groups, depending on if the customer wanted to get emails or anything about these alerts. They could do that. It was a very manual configuration because we couldn't handle that in our code back then. So we didn't really have that golden overview of what was actually deployed at each customer. We had to go and look at the configuration instead of just having it in our own code. Then the customers got our management packs, or what the name should be, packs of alerts that we defined for their servers. We have alerting to our on-call duty going through Signal 4, which is just an app where we get the alerts the minute they trigger in Azure. We also had I wouldn't call it an integration with Topdesk, but I'll go further into that. And this was all okay, but we didn't feel like we were finished back then. We still wanted to do some development, and the customers also had some requests. So some of the thoughts and considerations we made after we actually developed all this, we were quite surprised. It wasn't that easy to meet the customer demands in developing new features, but that was also because the code we had didn't scale to the extension that we needed. So we agreed that we couldn't stop here. We needed to expand our monitoring. Some of the features we got requests for was customizing alerts. So it was very static at that time. All the servers that a customer might have, we had the same threshold for CPU alerts, for example, across all of their servers. And that might work for some customers, but a lot of them actually came back to us and said, we need to differentiate the thresholds across servers. And also for disks and memory, and even for Azure resources, they had different needs for the thresholds. Some customers came back to us and said that in Operations Manager we have the concept of a warning. This is where we should start looking at things and prepare for cleaning up a disk or looking into CPU usage and stuff like that. And we also have alerts, and this is where we need to do something now. It's critical. And we didn't have that concept in Azure Monitor. We still don't have it in that extent, but to some point we can do that. Dashboards was also a huge request from our customers. We didn't think they looked into these statistics we collected, but they were actually quite interested in. Then we got some requests for doing patch management at customers. Yeah, a lot of them don't want to do patching in-house. They just want someone to manage it. And we have done that for a lot of customers previously, but it was very manual. And we didn't want to do it manual because then we need people to sit there and do it, maybe even off hours or in the weekends. And very few of us wanted to do that. So we needed an automated way of doing it. And then some customers also came back and said, we need to monitor the policies we deploy in Azure and if they're compliant. We also need you to manage the deployment of these policies. So we give you the full responsibility for that. And that was actually quite a big surprise for us. The other things we had already discussed a bit internally, but managing policies wasn't one of them. We also needed to look into the integrations we had. So some customers came back and said, we have ServiceNow. We need you to put an alert into our system and not have it handled by you. Others use Topdesk, and we do that internally too. So we needed a good integration to that. Of course, Signal 4, as I mentioned. And then we needed to look into our deployment, mostly integrating the deployment into ServiceNow, Topdesk, and Azure, and tying all those knots together. So the customizable alerts, as I said, some customers came back and wanted to differentiate the alerts they got. We had previously built solutions where we put all alerts into one ARM template. So, for example, monitoring Windows servers, this was all in one template with CPU, memory, disk, event logs, and all that. It was in one template. And doing a differentiation on disks with all this in one template was very difficult. So we split it into multiple templates instead, and did multiple deployments each time the customer wanted an update, because we needed to deploy a template for each alert type. And that was the first thing where we saw our mindset going into this, that we needed to change it and be much more flexible in the way we build templates and have a library of artifacts that we could pull from and deploy the alerts from. It's still easy to deploy now. Actually, it's easier to configure a new alert. But the way to get there was quite difficult, and we needed to wrap our minds around that. So patch management, we use Azure Automation, update management. We had used that before, and that wasn't no problem. At least we thought so. The APIs for that was, to be honest, they were quite bad. They weren't documented at all. How to do this with the template. The documentation that was there was wrong and didn't work. So we did a lot of work on that, and I'll be sharing that template too, so you can use that. Then we needed to manage policies. And we had a lot of design and considerations to do that. So let me show you the customizable alerts that we discussed.
Could you please zoom a little bit?
Yeah, sure. So the way we did this was, first of all, we split the configuration into multiple directories. So we have a customer database, and then we have our artifacts. The customer database is where we place new customers and put their configuration files. So a configuration file could look like this, or parameters file. We need a workspace ID. This is the log analytics workspace. We need an action group ID. This is the Azure Monitor action group, the ID of that. And then we have the servers we need to configure. And we could just add a new server in here every time a customer wanted a new server monitored, or if they wanted a different alert than the default one we had configured. And then we have the artifact, which is the hierarchy for the folders is artifacts and then templates. I'll show you more of this later. And then it's split into the scope of which we're deploying to. So we could deploy at resource groups, at subscription level, or at management groups or tenant level. To have a template used like this, you need to heavily rely on parameters and variables. So we have some configuration that is the same across all these alerts. We could put the description into a parameter, the same for all these others, but where we are now, this is the good configuration for us. And then for each server we put in the parameter file, we create a loop. So as you can see here, this is configured as an array. And in the template, the parameter is also defined as an array. So this was one of the hard ones for us to figure out in the beginning. We have a parameter called servers, and then we do a loop, which is a copy index in ARM templates, where for each of these servers in the array, we look up the server name, and then we configure the alert type too. So some of our customers had this requirement to have warnings and alerts, and we would put that into a property on the array called so it's actually not in this one, but we had it is. So we had warnings and exceptions for some customers, and we could add that into the name of the alert so they could react on that in their ITSM system.
Can I ask one small question?
Yeah, sure.
These parameters or functions within the parameters that you get, where did you get those functions, and are they documented somewhere specifically for? Well, at least I've been searching for them myself, and there is no. It is not specifically well documented as I seen it.
Well, yeah, it is actually documented, but the problem is getting an example, in my opinion.
Yeah, debugging is the issue itself.
Yeah.
Hard to debug.
We heavily relied on Google for this.
Yeah.
and looking into other GitHub repositories for seeing this code, finding somewhere where did they use copy index to look up an array in a parameter file. So it was a mix of using Google and looking through GitHub repositories, with something that looked like what we were building. The copy index feature is actually very well documented. If you search for ARM template functions, the problem is using it in this situation. So we had to figure out how we did that. But this is a very good starting point to find the functions that you can use. Copy index is here, for example. I'm not sure if there are new examples, but yeah. So that's probably the best way to find what you're looking for, than using the name of the function in a Google search or something like that. Then actually for each alert that we deploy, it runs through this full template, and using one server at a time. So the deployment will go through this, and there are some metric names and server names that needs to be included. There's description and the severity of the alert, all that. And the actual alert here is split into two different resources. So the first resource is a scheduled query rule. This is only needed when it's not an Azure VM that you're creating this alert for. So if it's an on-premise VM or in Amazon or wherever you run it, the server is sending the logs to Azure Log Analytics. And from there, you need to create a scheduled query rule, which will make that log into a metric. And that's also what we can see down here in the data type. It's a log to metric action. So it's actually converting the log entries you have into a metric. And then after that, we're creating a metric alert. The same way we build the other resource up here, going through the same array of parameters and creating the actual alerts that we need to deploy. We can just take a look at the portal here. And alerts. So here I have only one server in this environment. So it's only created one heartbeat alert and one CPU usage alert, because that's the ones I defined. And the CPU usage alert will just look into this Log Analytics workspace and create the alert from there. Yeah, that was customizable alerts. We also needed to look into our integrations. ServiceNow, we had one customer in the beginning where this was another managed service provider, actually a hosting provider. They were using ServiceNow and had a custom module instead of the incident module in ServiceNow. So they couldn't use the Azure integration, the Azure Monitor integration for ServiceNow to query the alerts. So instead, they wanted the alerts on emails, and they wanted an email when an alert fired, and one for when it was resolved. And the formatting of each email needed to be different, so they could open and close tickets. And after we built this on Logic Apps, that it was very difficult to maintain, and we couldn't we couldn't reconfigure it for special scenarios as easy as we wanted to. Then we had our own system, Topdesk. We started using emails also, but our sales guys got tired very quickly because they needed to handle two tickets in Topdesk every time we got one alert and it closed again, and manually sitting there closing tickets to check and if there was a deactivated alert. And so with our learnings from this customer environment using Logic Apps, we thought there must be a more flexible way of doing this. So we ended up using Azure Functions, PowerShell-based function, and we use a Topdesk PowerShell module that was developed by the community. Right now, it's a proof of concept. We just got it working a month ago or so. It's been very busy, so we still need some polishing before we publish it, but it will be published. So let's try and look into the Topdesk integration. So we have our Azure function. Azure functions are just a way of triggering a script or a piece of code and have that run and do some things. So this is triggered when a new alert pops in. And then it runs this PowerShell script. So, as I said, this is still work in progress. But when we trigger a function, we have a request and we have the metadata for that request. The request in this case is the alert from Azure Monitor. So there are some samples that you can find with the alert data in it, and we use that to build this. Then we have some parameters. This is something we are planning to put into the deployment instead, so we can use it differently and have this more flexible. If we need to deploy it to a customer, for example, it shouldn't be a Solvo IT environment or Topdesk. So we need to move that. Then we have some credentials for Topdesk to create the ticket in Topdesk. We actually store this in Key Vault in Azure, and I'll show you that. But the function, when it starts up, will pull this from Key Vault. So every time it starts, it will look in Key Vault, find the secret, and use that to log into Topdesk. we have some different functions here to make it work and create a ticket in Topdisk. So because we use some special characters, we need to do some lookups because Topdisk can't handle if we create a ticket and put this into the parameter. So we need to find the ID behind the scenes in Topdisk. Everything in Topdisk has an ID instead of the display name. So we need to look up IDs and stuff like that. What we actually do is just need to find it now. Yeah, so if the alert is a new alert and if it's fired, we need to create the ticket in Topdisk. Then we get all this information from the alert that we get from Azure, and we store it in the ticket. And we are doing differentiation on metric alerts and log alerts, and also activity log alerts. I think this is an old version of the script. There's missing some code here. Yeah, but you will see all this. It will be published probably after New Year to GitHub, and you can find it there. One of the tricky things we needed to find out here was when we deploy this. As I said, the function is looking for Topdisk secret in Key Vault. So we needed to put that the secret into Key Vault. And we didn't want to trigger this manually, so of course we needed to do this as part of the deployment. So the secret for Topdisk is actually stored in GitHub secrets. And when we trigger a new deployment, we pull that secret from GitHub and use that in our deployment. This is a GitHub Actions pipeline. You'll see more of that in a minute too. So when we deploy it, this secret is coming directly from GitHub and stored with the customer Key Vault. To be able to do that, we needed to have our Azure function. It should, first of all, it should have permissions on the Key Vault to read this. And we use Key Vault here where we assign a role to the function. So the function has a managed identity where it can look up, the managed identity then has a role where it can look up secrets in the Key Vault. So this was another tricky one, this particular one. Figuring out where to find the ID of that managed identity of the function app. And once again, looking through the documentation, you can find some examples, but this exact situation, we weren't able to find anything from there. So again, it was a lot of searching on Google and looking into GitHub repositories, and we finally found how to look up the principal ID. This is just for you to know when you sit and configure this, it will make a lot more sense. And we also, on the function app, the actual configuration, we can just look at this in the portal. So in each function app, we create the these application settings. And we have keyboard name configured. We have the top is secret put in here. And the URL for top disk and the user it's using. So every time the function we have starts, it will look up those secrets and use them in the code. This is a very cool feature of Azure Functions, where you can test the code. You just need to supply a body of the request that it would get from, in this case, Azure Monitor. I have that somewhere here. Didn't I? You can also search for them here and find the alert schemas in the documentation. So here's an example on a metric alert. This is the data that you get and could put into a request in your Azure function and have it run. Now I don't know if this exact function is working because we have a lot of testing going on. But this way we could just start the function and go through the flow. And this was a new alert, so it will probably fail. Yeah, it did. So what happens when we create a new top disk ticket is we actually use this alert ID. We split this and we use this ID here as an external number for top disk to know where this come from. So when we need to close an alert, it's triggered from Azure, and it will look up the alert from this external number and then close the ticket. This is what we can see. Up here. So instead of just looping through all tickets, searching for the correct customer and the correct description and all that, we're looking at from the external number. Moving on. The deployment of all this was a big challenge for us. As I said, we had a PowerShell script that we ran manually every time we got a new customer or a customer wanted a new alert or something like that. So we were looking into using either Azure DevOps or GitHub Actions. And we ended up using GitHub Actions mainly based on our feeling around how easy it was to use. We felt like GitHub Actions was the best way to get started quickly and felt more lightweight, so we could just start developing and not spend a lot of time on learning instead. But we still needed a lot to learn, mostly around deploying software and doing it to multiple customers. So we had a lot of thoughts around that. Mainly because, as I mentioned, we needed to reuse all the artifacts, the templates we create. Building blocks, it's also called in some repositories when you're looking into this. But we had this requirement that we needed to be able to reuse everything we make, even if one customer has some special configuration. Because we've seen that sometime in the future, another customer will come around with the same requirement, and then we wanted to be able to reuse it instead of developing it and copying code from other places. Then we needed to be able to deploy at multiple scopes, as I also mentioned: tenant management group, subscription, and resource groups. And what we saw was that we needed a separate folder with the customer configurations. So we called it a CMDB. This was quite an eye-opener for us. We had some configuration files lying around, but we needed to be way more organized about that than we were. And we actually got quite far in this development and had it working. But we still had some things that we needed to develop to make it really nice. And we were starting to look into that, and then we got to talk with Microsoft about it. And they said, "Hey, we have something like that built already, and maybe you need to just take a step back and look at the code, see if you can fit this into what you actually want." And we did that and had some discussions with Microsoft about it, and we ended up saying, that we need to start over on some of this. Sorry about that. I think my phone just rang and it took the headset. So could you hear what I was saying?
Yeah.
Okay, perfect. So yeah, we took a step back and we admitted that we needed different layout for this, a different structure. So Microsoft has this GitHub repository called multi-tenant landing zones, which was very much what we were in the process of developing ourselves, but they had gotten a bit further. So we made the switch to using that actually just 2 weeks ago. So it's still in progress, and we still need to move customers into it. But that's just minor work compared to what we needed to develop ourselves if we should build something as good. So now we have some new flows for creating a new customer or creating new artifacts to deploy at a customer. So every time a new customer comes around, we create a new branch in this GitHub repository we have. We copy a baseline customer configuration we have into that customer configuration. We create a service principal for the customer subscription, for the customer subscription, and we store that in GitHub secrets. Then we add the artifact parameter files that we need to use at this customer. So this is the baseline configuration, and on top of that, the special configuration that the customer has. We also copy a pipeline from a customer, from a baseline customer. And then we commit all this, and some tests are run on what we have actually built. And then we create a pull request if the tests are successful. This will trigger a full deployment to that customer subscription, and all of our configuration will then be deployed. For creating new artifacts, new ARM templates, or just a simple alert, we also create a new branch. We create the artifact we have and test it in a development environment. So every time we commit in this branch, it will trigger deployment so we can see it deployed in Azure. And it will also test the code that we create. most of what Microsoft had built in this GitHub repo is all this testing of the code. We hadn't got to the point where we even wanted to look at that, but now we got it in this package from Microsoft. If the tests are successful, we will create a pull request to have this code into the main repository or the main branch. But the test will go through, and then it will upload all the code to a storage account in our tenant that we control. So all artifacts are living in storage accounts and are deployed from there. Only the parameter files are actually local, and local in the sense that it's in the GitHub repository, and when we run a deployment, the server running the deployment will have access to those parameter files. So after creating a new artifact, we will have to go through the customer flow of adding in a parameter files for that specific alert or whatever we just configured. So let's try and look at that. So this is what that repository looks like. We have some different folders here. We have actions, which is just a custom action to use in the actual pipelines. This is all the pipelines that are available to use. So it's also creating a new wiki in your GitHub repository if you have access to that feature. Documenting what you just deployed at a customer and which customers has what configuration. All this will trigger at different actions. So, for example, if we create a new artifact and want to publish that to our storage account, we create a pull request, and when it's closed, that's this pull request, meaning that we approved the change on the main branch in the artifact folder, then it will run through all this and upload all the artifacts we have. So that's a PowerShell script for that, which Microsoft made. And after it's been running, the artifact will be available in that storage account. I'll go through creating a customer in just a second. We have this folder here called Platform Automation. This is where we store all the code, all the ARM templates, all the parameter files and stuff like that. So we have artifacts here, different artifacts. It could be Azure blueprints, it could be dashboards or DSC configurations for configuring servers at customers. We have policy definitions. So if we need to deploy a policy, we store the definition of that policy here. We also have role definitions. If there's some special role a customer wants, we can build that and deploy it to their environment. Scripts, we haven't gotten into use that yet. Then we have all the templates. As I mentioned previously, we are deploying at multiple levels. So for each level, we have templates lying here. This could be a management group configuration, like deploying Azure Lighthouse to give access to our consultants into the customer environment. It could be assigning policies on management group level. Yeah, all kinds of resources. This is what we have for deploying at resource groups. So it could be a virtual network, a VM, a storage account, key vaults, alerts that we use. And again, this is just like what you saw previously. We have a configuration where we have the information for the alert. We have a workspace ID and an action group ID. And then we create the actual alert in this template here. Action groups also, we needed to deploy that for us to have this function trigger when an alert is fired. And And we're looking into expanding this. Every time we create something new now, we'll put it into this repository and make it parameterized to be able to deploy in here. We can also deploy workbooks for Azure Monzo, for example. So the CMDB is built with first customers. We also have some work going on to making lists of customers and updating those so we can use it in other environments. So each customer has their own folder here, and then they have a manifest file. This is where all your configuration for that specific customer is written. So if we need to deploy a new resource group, for example, we'll just add a block of this. We can actually try and do it now. We'll just call it like this. So this is the name of the job that we're trying to deploy right now. And then we have the type of deployment that we're doing, and it's at the subscription level. So if we go through our parameters here, we will look at subscription level, and we need to create a new parameter file here with the name of the resource group and the location it needs to be deployed to. Just this. And then we need to rename this file. So it needs to match the name that we gave in the manifest file. I think it was something like this, right? Yeah. So this name here needs to match the first part of the name here. Because it's a resource group deployment, it needs to be named resource group and resource group in the manifest file too. Using this, we will be able to look up the artifact we have here, looking at templates, then for a subscription, because it's a subscription level deployment we're doing, and then the template named resource group. And we can see what parameters are needed here and know what we need to put into our parameter file. So if we save this, we can start a deployment. So typical. It just worked when I did it before. Oh, yeah. That's the thing. Can't make any mistakes. And this is looking good. So this deployment script I'm running here is just the script that is also running when we deploy this from GitHub. This will take just a moment, so we can look at GitHub. So in GitHub, we have all the code lying around here. Sorry about that. So deploying a new customer, this will also run, as I said, on a pull request when it's closed. And we tested the code and everything. And then it will run. First, it will log into Azure using. First it will install the modules we need to deploy this, and these are also documented. Then it will log in to Azure using the credentials we have in GitHub, and then it will run a deployment. So as you can see, it's the same script as I just ran locally in VS Code here. So that way you can test the deployments without having to create a commit and a pull request and having it trigger all the time. You just run the scripts directly here. So it actually already deployed the resource groups, it seems. We have the deployment here. And it successfully deployed it. So if we look at the portal, we should now see a new resource group. If we select just that subscription. It's not there yet. Well, it will show up here. It's usually quite fast. Anyways, the deployment was successful, as you could see. Yeah, not sure why it's not showing in the portal yet. So that was pretty much what I had to show you. I just want to say that this is still development in progress. I will send the links and some slides for Gisli to share with you, so you can get the links for these different GitHub repositories I mentioned. And when we're ready to publish the top disk integration, we will also send out that link for you to use. With this said, we're not done yet. We have other things we need to automate. For example, creating new subscriptions. This is a manual process right now, but we can do this through our CSP we are working with. They have an API for that. Of course, we continue to build new alerts, even adding other artifacts, and we also look into creating landing zone references that we could deploy at customers. We talked a bit about creating a web interface for adding new customers, but again, we have no developers in-house, so we need to figure out if this is something we will look into. Is there any questions? I know this was a lot of information.
Yeah, this is a lot of information, but this is actually very, very, very exciting topic, at least for me, since I love automation and very interesting things that I saw there.
Yeah, I know there was a lot of information here, and with an hour to do it, it's a lot of things to go through. So if anyone wants a deeper look into this, feel free to reach out to me. I will also try to do some videos on YouTube on this and do some blogging around it.
Yeah, I'm definitely going to do a very deep dive on this. So I will definitely contact you on this. I was also thinking maybe it would be interesting, like doing a Power Automate link into this, if that would be something that would be interesting to do. That was just a thought on this, but anyhow, if there are any questions, just unmute. If you have any questions, there are a few people here.
Yeah, one question from me. You talked about YouTube. Do you have a YouTube channel already, or?
Yeah, I do, but there's one with video in it, I think.
Oh, okay.
And it's like 3 or 4 years old. So I will be doing some videos on this. I've kind of needed to have a situation or a topic to do on YouTube, which was fit for YouTube. So this is what I'm planning to do. Yeah.
Awesome. I'll follow your Twitter and look forward to seeing some on YouTube.
Yeah, perfect.
It's always the same. Icelanders are pretty shy. As you know, you've already been in Iceland, and most of people that are asking questions are like one or two, but it's quite common that we don't really like to ask questions.
Yeah, there's no worries in that. Feel free to reach out on Twitter or email or anything if you have any questions.
Yeah, definitely will do. I'm looking forward for the links. I'm going something that I'm going to dig into over the holidays.
Yeah.
So with that, thank you for this, and yeah, thank you for giving us your time.